Okay, we have another division problem here. But what's interesting about this one is the second expression that's there does not appear to be a rational expression. But if you recall, anything, you can put a 1 underneath and it doesn't change it because dividing by 1 is the same thing as not dividing by 1. You get the same result. So with that in mind, this problem is very similar to the last one. It is dividing two fractions. So I'll keep the first fraction the same. And the second fraction, well, I'm going to change it to multiplication. And for the second one, I have to take the reciprocal. So that means the old denominator becomes the numerator, and the old numerator becomes the denominator. Okay, so now once again, rather than trying to multiply the tops and multiply the bottoms, I'm going to factor first so I can look for things that can be canceled out with the numerator and the denominator. Now my first numerator is a little bit more interesting factoring problem. So I'm going to do a little bit of scratch work on the side for this one. So I would need to start by taking 6 times negative 3, which is negative 18. And I'm looking for things that'll multiply to make a negative 18 and add to make a positive 7. So after a quick run through their factors there, I would say that that's negative 2 and positive 9. But because these numbers exist, that means that that thing is factorable. And so now I can come over here and work on factoring it. So for the 6x squared, I'm going to focus my attention just on that for just a moment. I could write it as 2x times 3x or 6x times 1x. Now if I did 6 times 1, I put a 6 here, then I would have to find something to write in this position right here that I can multiply by 6 to get one of my target numbers from over here. Now you can't multiply 6 by any whole number and get a negative 2 or positive 9. So 6x and 1x is not going to be a good choice for this one. So instead, I'm going to rewrite it as 3x and 2x. Now I'll say 3x times whatever I put in the last position there has to equal either negative 2 or positive 9. Now 3 times a whole number is not going to give me a negative 2, but I could multiply 3 times a whole number and get 9. That would be a positive 3. So I'm going to put a plus 3 here. So that outside product there is going to be positive 9. Then my inside product, the other blank space that I have there, when I multiply 2 times that number, I have to get the other target number. So 2 times something to give me a negative 2, that would have to be a negative 1. Now for my first denominator, I've got a 6x squared, and I know that I could break 6 down into 2 times 3. However, if I'm looking in my numerators, the two numerators that I have there, I don't have a 2, a 3, or a 6, so I think I'm going to leave the 6 alone. Same thing with the x squared. I could write that as an x times an x if I needed to, but I don't have any x's hanging out by themselves in the numerator, so I'm just going to leave that one alone too. That's just going to be 6x squared. Now for my second numerator, it's just a 1. Nothing really fancy I can do with that, or that I would need to do with that, I think. For my second denominator, I've got a 2x squared plus a 3x. So there's only 2 terms there, but it's still quadratic. Now remember, the first thing you're always supposed to look for when you're factoring is a greatest common factor. So looking at the 2 terms that are there, I do have an x in common. So I'm going to factor out an x. What times x would give you 2x squared? That would be 2x. And what times x would give you 3x? That would be 3. So now I need to look for common factors from either numerator with either denominator. So at a quick glance, I'm getting pretty good at this now. So at a quick glance, I can see that I can cross out 2x plus 3. One from the first numerator, one from the second denominator. The only other factor I have in my numerator is 3x minus 1. And there is no 3x minus 1 in either of the denominators. So that means that's as far as I can go. So I just need to write my solution now. In the numerator, I've got a 3x minus 1 times 1. So that's just 3x minus 1. In my denominator, I've got 6x squared times x. Now, if either one of those was a binomial expression, I wouldn't actually combine them, I'd just leave them factored. However, since they're both monomials, I'm going to go ahead and multiply them together. So 6x squared times x would be 6x cubed. That turned out kind of bad. Try that again. 6x cubed. There we go. Okay, so now this is as simplified as I can make this expression. Now you're going to try number 12 and answer on the Google form.